Okay, talking about cold fluid applied roofing membranes, you guys know we spoke the class prior about coatings, and we talked about coatings that were just restorative in nature, designed to an existing roof to block the UV rays to make the roof system last longer. So then what we did is last week we talked about cold fluid applied membrane roofing. This is cold fluids. Those cold fluids are applied on top of a roof that we use as coatings. Well, these can act as a roof membrane.
Back here?
These are complete roof membranes. I talked about a little bit about employability skills and training. Fabian, somebody's got to mute. I got Fabian. I'm just picking up a little background noise, please. And 10 essential employability skills: problem solving, oral communication, adaptability, collaboration, resource management, organizational skills, written communication, technology use, information, stuff that we've been talking about on a day-to-day basis throughout the year, you'll notice. Again, same quote, I'm just running through the program. Love is the only force capable of transforming an enemy to a friend. The resource I used for this is the one from the program, which is a cold fluid applied membrane roofing. I did give everybody access to that also. So hopefully you had a chance to take a look at it on SharePoint. If you didn't and you can't access it, feel free to reach out to me. I'll make sure you can access it. There's a lot of benefits to cold fluid applied roofing. You know, they fit around a lot of different surfaces, so they're very versatile. We use it as flashing on a lot of systems, as you know, as termination flashing. So for penetrations, etc. You know, in fact, we had a couple labs where we were cutting the fingers using cold fluid. I know the guys in Orlando, we did that, and then in South Florida also. So we've had some cold fluid experience as far as the detailing goes. Well, this is the whole roof system being cold fluid, and it may or may not have a membrane reinforcing in it. It depends on if, typically not only what substrate that you're going over, but what application. Are you going over an existing roof as a recover, or are you putting on a complete new system over a substrate, for instance, such as Den's deck? Frank, do you have anything to add to that? You're muted. Hold on, I gotta unmute you. I'm sorry, go ahead.
No, I'm sorry. I was messing with my computer right here, and I honestly wasn't paying that close of attention like I should have. I apologize.
No worries. I was just talking about the cold fluid, so I'll come back to you.
All right.
Roof coating, cold fluid applied membranes, and waterproofing. We want to understand the difference in that. We're going to talk about that. Two major classifications of cold fluid roofing: determine suitable substrates, understand the application processes, review common flashing details, and construct a reinforced cold fluid membrane system in the lab. Well, we have a lab coming up where we're going to split it both between cold fluid and EPDM to make up for both of those labs. So again, what I'm trying to do is use everybody's time as economically as possible for the rest of the semester. I realize now that's why we typically try not to do this program during rainy season, because we understand the stresses on your companies, because this is when we're making our hours typically too. So what's the difference between cold liquid membrane roofing system, waterproofing, and coating? Because they all come out of a bucket, and a lot of times they all have the same base material, whether it be an acrylic, a polyurethane, or a PMMA or a Puma system, which we'll talk about today. So again, here we're talking about cold fluid systems that can be used as roofing. So it's actually waterproofing for the roof. It's fluid applied, it's monolithic. There are no seams at the end of the day. There's a lot of challenges with that. Most of the time when we have TPO roofing, those roofs are constructed in a factory under ideal conditions. Well, these roofs, when you constructed a fluid applied roof, you're building them outside, often in not ideal conditions, especially when you're trying to do it at this time of year. It can really be a challenge. You guys know, by the time you get it swept off and dried, you're looking up and you can't put any product down because it's going to rain in an hour. So there are a lot of challenges with using coating systems at this time of year. Again, so waterproofing is pretty much everything else similar to the cold fluid applied at the roof, but on the rest of the structure. And we talked about a roof coating just being designed to reduce the UV and extend the life of the roof. The cold fluid systems have been increasing in market share steadily and for a lot of reasons. The price points are coming down. The systems are getting better. They had some early failures in them and kind of scared a few people from getting into them. But recently, the formulations that they have are performing great for the applications that they're put on, provided that they're put on correctly. And you make sure that you are checking your ambient conditions all the time. Since fluid-applied membranes are flowable prior to curing, they have the ability to conform. Like I say, you can put them on many different shapes. They resist hydrostatic pressure, so they're good for low-slope applications where you have ponding water. Those are hydrostatic conditions as opposed to a sloped roof where you have water shedding condition. Okay, we talked about the differences in that being hydrokinetic. So what I'm going to talk about today is acrylics, polyurethanes, and PMMA. That's polymethyl methacrylate, and pumice systems, which are modified urethanes, methylcrylates. So again, those are the things we'll be talking about briefly today. And what I want you to know in the I try to reference NOAs in the code for you. You'll see here, these are liquid applied roof systems. That is a subcategory of roofing. A lot of the coatings that we talked about in the previous class that just protect the roof, they're classified as coatings and adhesives. So this is a separate category, again, that can be permitted. Talked about elastomeric, was a term for a rubber-like coating. Acrylics are the most popular. What it means is typically they're characterized by more than 100% elongation capacity. We talked about elongation, being able to pull the material and stretch it. 100% means you can double the size of it. What's in it? Pigments, fillers, modifiers, and we talked about that. Somebody have a question? But one of the main things I wanted to talk about today and make sure, again, that we walked away with, we all used the mill gauge when we did coatings. But I want to make sure that you understand the concepts of solid by volume or solid by weight and total solids of a product. When we look at the acrylics, some of those acrylics can be 50% solids. Well, this is a good example right here, some that's 50% solids. When you look at this picture at the bottom, all you got to do is look at the picture and know if something that's 50% solids is half solids. So that means half of that is something that's going to go away. It may evaporate. It may cure out. And it's going to go away. So what you're going to be left with is half of the original wet film thickness that you put down. So at 50% solids, when everything cures out, your dry film thickness, if you put down 16 to begin with, you're going to have half of it at 8 mils. And these products that we're talking about today, specifically these urethanes, they're 100% solids. So if I put down 32 mils, because Frank, the project you're doing, I think I was reading at least the base or the top coat went down at 32 wet mils, and it's 100% solid. Anybody want to tell me how many dry mils you're going to have? If I put down 32 wet, is everybody muted?
Sí.
Well, if it's 100% solid,
32.
32, Elijah.
Yes,
Good.
sir.
Okay, I'm sending you the Uber Eats. That's not going to Uber Eats, but I just turned it into one. Okay, so excellent. You're right, because it's
Yes, sir.
100% solids. That means 100% of the material is solid. So when it dries, it's going to stay there. So if you put a wet film down at 32, when it dries, you're going to have 32. If it was acrylic and only 50% solid, when it dried, you'd have 16. So again, one of the things I want you to walk away with from this module is the concept of percent solids and wet film thickness versus dry film thickness. We did the thing, you guys did the lab. We used the mill gauge and we looked at it when it went down wet, and when it dries, again, depending on the percent solids of that particular product we were using, that film thickness is going to change. That's why with an acrylic, because they're low solids, you tend to have to put down 2 coats to get the millage that you need. You guys have put down silicones, know that a lot of times those silicones are high solid, 96, 98%, that you can put it in one pass and it'll stay there, okay? And you can get the millage you need for your warranty in one pass. So there are a lot of terms. Dry is not cured. So if you tell me, hey, the coating's dry, I'm gonna ask you what kind of dry? Is it dry to the touch? Is it dry to recoat? Is it dry that I can walk on it? Or is it dry that it's cured? Because cured's completely different, okay? Cured means it's done. You're either cured or not cured, like pregnant or not pregnant. So cold fluid applied product considered cured when it's achieved its ultimate performance characteristics. And Frank, talk to me about cure times on the project you're on, because one of the things that's critical, you put down a single component product or a dual component product, and you're using dual component products out there. So when I talk about dual component products, and I'll get to it in the program in a minute, is that I mix an A and a B component. So, and tends to be that one of them is something called a catalyst. It's a catalyzed reaction. So I put a catalyst and a base, those two things mix together, and a chemical reaction occurs. That's how that cures when I have a dual component product, by chemical reaction. So if I get a chemical reaction going on, I have a certain cure time. So if I open up a bucket of single component product, I can use it all day. If I mix 2 products together, I probably got to use it in 30 minutes max. If it's hot out, it may only last 15 minutes before it gets hard on me and I can't put it down anymore. So different curing mechanism: evaporation, that's where the water, for instance, just evaporates; oxidation, reaction with moisture. You guys know that silicone, moisture cured. So you take the lid off the bucket, it automatically starts to cure just from the moisture that's in the air. Frank, on that project you're on, recoat windows, what do you look at between the time you put the first coat down and the time that you put down the successive coat? And if you don't hit that window for any reason, what do you got to do?
Well, what we're doing on this building, we're doing on a Fort Myers, is that we're doing a 2-part epoxy primer. Once we put the primer down, the dry time is 3 to 4 hours. And then after that, we put down the first base coat, and then we immediately press in the fleece polyester, and then we follow that with immediate the second base coat. And then we wait, and we'll come back the following day. We have 3 days to come back to do the top coat. And that's for the Tremco products. When we're doing the C-Plast Parapro 123, it's almost the same thing. We have a 45-minute dry time for the primer when we're using the concrete primer. And then we just, after that, it's just immediately processing of the base, fleece, and the second base coat. So
I guess one of the critical things that I'm hearing is that each system is independent. They're all different. The application process is critical on these products. What you're doing, again, is you're building the roof in the field. So you've got to follow your cure times. And you said dry. Maybe, you know, so we were talking about cure, and I was going to ask you, which dry are you talking about? Dry to recoat? Dry to walk on? Or cured dry? Because I know if I'm doing an adhesion test, typically I got to wait like 72 hours to do the adhesion test to get to a level of cure, correct? That's acceptable?
Yes.
More?
Yes, when I was talking about dry times, I was talking about the recoat time, after the time to recoat. But yes, you're right. After you do, or when you do your adhesion test, it's a 72-hour.
And again, adhesion, again, we talked about it in coatings when we did the coatings class, but the same for liquid applied is adhesion is key. So again, one of the main things I wanted you guys to walk away with from this module was being able to do an adhesion test. And some of you I got back with, we looked at that because we embedded the fabric and then we're gonna pull on the fabric. So I didn't ask you to get a scale. I just wanted you to pull it with your hands to kind of feel difference between the different substrates that you get a great bite at typically out of modifieds because of the porosity of the modified felt. You get a good bite out of metal too, but you don't get a great bite out of the single plies that we looked at. So, and when you do those tests, you need a 1-inch wide strip. When you cut that fleece and you embed it, and I saw some, when you sent me the pictures, some of you put the whole 3-inch that I sent you. But in my video, I showed cutting it down to 1 inch because the test requires 2 inches over a 1-inch wide strip. So if you're doing the test and you use 3 inches, to me, then you need to have 6 pounds of pull, 3 times that amount because you use 3 times the width of the strip to do that. But anytime you're doing these coatings, adhesion is key. And adhesion has a lot to do with a lot of things, the compatibility of the substrate to the coating, the surface contact area. And when I say compatibility, I could mean the fact that that surface wasn't cured or dried enough, that the substrate that we're putting it on, if it has a moisture content in it that is too high, you're looking at problems with your coating application. And we'll talk a little bit more about that when we get it, because we have a project right now that we're learning on, for lack of a better term, because every project tends to be different and have its own unique challenges. So,
Are you talking about the GSA building?
yes, sir.
Yeah, that's the thing. When I did my when I did the moisture test, because Tremco was supposed to do a moisture scan, they said that they didn't have to do one. Well, after the fact now, when I did my readings, I got between a 16% to 23% moisture. So that's going to raise some red flags because 4% was maximum of moisture for the concrete. So just a quick story. They were out last week. Actually, they were out on yesterday. They were out there. The Tremco came out to do a test. Glenn and I were out there prior to them showing up, and we found some cohesion issues going on, adhesive issues going on, and so when Tremco came out to do their test, they saw what we did, and they just went back to the drawing board to come up with a different game plan to figure out what's wrong with their system. So they're trying to figure it out, and so are we.
All right, so Frank brought up a couple good points. Adhesion, cohesion. So when you guys the test strips that are in the samples that we put down, and the material separates from the substrate, that's adhesion. That's adhesive failure. If you make the 2 pounds that's required for your coating, it's not failure. It's adhesive, it passed, but the mode of failure was adhesive. If the coating itself rips apart, that's cohesive failure. The coating itself ripped apart. And that also goes for caulk. So when we did our caulking module, if you remember, we looked at 3 failure modes for caulk. We looked at the adhesion failure mode of the caulk to the top. We looked at cohesive failure where the caulk split apart in itself. All right, somebody got something going on in the background. I'm going to try to mute everybody. And okay, so the chemistry has a lot to do with it. What chemistry are we using? But what makes good adhesion more than anything else is preparing the surface properly. One way or another, and we're going to talk about surface prep too. We talked about acrylic coatings. Okay, I'm going to run through these quick because you guys know you use acrylics. We talked about polyurethanes. So you're using polyurethanes a lot also. Less permeability in a polyurethane, around 1. The acrylics can get high. The acrylics will absorb a lot of moisture too. I mentioned when I did my test, I left my 2 samples, my acrylic out and I left my silicone out. Well, when it rained and they got wet, my acrylic grew because it absorbed moisture. My silicone did not. It stayed intact. We talked about polyurethanes being either a single component or a dual component product. If it's single component, you got to watch your cure times, okay? Dual component, like I said, it is going to cure by chemical reaction. You got an A and a B you're putting together. When applying these products, manufacturers don't recommend inverting the buckets. That's one of the things I read about. Again, as I do these programs, I learn. So, and I don't know if Tremco's ever said anything about it on that job, Frank, but one of the things I saw is for some reason, you don't flip the bucket upside down and drain them out. I don't know if it has to do with the mixing, and maybe you're getting a little bit too much of the product, but it's just one of the things that they said. I was curious. Urethane terms to know. Aromatic and aliphatic. You'll hear them when people are talking about urethanes. The aromatic coatings are not as UV stable, so they're usually used as a base. So if you're putting down a two-coat system, chances are pretty good the first one you put down is going to be an aromatic. The second one you put down is going to be aliphatic. Well, the aliphatics tend to have better UV resistance. They're going to hold the color, they stay cleaner, hence they end up being on the top coat. Natural and bio-based products, you'll see those out there. Well, everybody wants to be green these days, so bio-based products have some type of natural oil in them. Typically, soybean or castor bean oil is added to it, but people love that. It's sustainable. That's an ecological term there. They want to use all the time. So it makes it more sustainable. They get lead points from it, maybe, because they're recycling. It's like ethanol in your gasoline. So, and then Puma. We talked about PMMAs and Pumas. So a PMMA, polymethyl methacrylate, is an acrylic resin. So really, when you're putting this down, you're almost making like a plastic roof, a solid plastic roof. It tends to be harder. It tends to be brittle. That was the knock on these. And these products are hard. I mean, they're great. They use them a lot of time for parking garages, etc. Things you're going to be driving on, things that really need a tough wearing surface. Again, typically the PMMA systems go down, like Frank was saying. Is that the Parapro PMMA, correct?
Correct.
Correct. So what I'll try to do, Frank, if you can, is based on what we're doing as we go forward, if you can capture some of the nuances of that PMMA and bring them back maybe to the class.
I certainly can.
Yeah, no, that would be awesome. Just especially in differences between that and the Alpha Guard that we're doing. And PMMAs, again, so what happened is that they aren't flexible. If you guys remember and you watched the video that came from Tremco, you looked at them doing tensile tests where they pull them apart on both a PMMA and a Puma system. Well, the urethane of the Puma made that thing stretch like 400 to 600%. So you get the quality characteristics of the PMMA with the Puma, plus you get so much more elongation, like 10 times more elongation. So the flexibility really makes these Puma systems attractive, and you're seeing them more and more in the marketplace. Some of the names of the manufacturers, if you're familiar with them in the marketplace that we see that develop these systems, Suprema, C-Plas is a Parapro, Paradigm. We use Alsan. If you guys use Alsan and use Alsan RS, that RS stands for rapid set. That means you got to use it quick because it's setting rapidly. So again, you got to be cautious. When you're mixing two component materials, always make sure you're ready to go because you got a pot life on them. So they're gonna terminate, so to speak. They're gonna get hard in the bucket. So if you're not ready to go, it can be a problem. Also, these products have critical mix times on them. When you're mixing a two-component product, you need to tend to mix the base product by itself first, then pour the catalyst in, and then continue with a timed mixing. Okay, there's an amount of time they require that you have to mix. We talk about just good practices in mixing. Don't pull the mixing bit out of the product and put it back in the product. Otherwise, you're going to air and train the mix. You're going to put air bubbles in that mix, and those air bubbles can be a problem because those air bubbles will stick around. And if you get a blister a lot of times in an air bubble, it will telegraph right down to the concrete. So you'll have right down to the concrete a bare spot of concrete. You'll see it right in your base coat. That's a problem because if you put another coat on it, you're going to get that same spot. It's not going to go away. I made a mistake on a job once. I tried to code over it 3 times. It never went away, and I took the whole thing off. Just take it off at the beginning, trust me, and get it over with when you have a problem. Manufacturer, do your due diligence, and that's one of the things that Frank just mentioned. And we'll talk about different tests that you need to do. Surface moisture, humidity. You know, I like to do the moisture in the air even, because certain relative humidity is the same as rain. So you need to know that. And a lot of times what they'll do is tell you, like on dew point, you have to be 5 degrees beneath here. So these qualifications to put these systems down are critical. You need to follow them. You need to document them on a daily basis. When I was out there with you, Frank, you were timing the mix and taking photographs of them timing the mix. So if anything ever came up at a later date and somebody said, well, you didn't mix it right, it wasn't mixed right, it'd be nice that you have pictures in your file that you can fall back on where you're standing there and holding the clock and filming it above the bucket, okay?
That's exactly what we did too. That's what I was going to recommend, is that documentation is everything. When you're out there on the job site, millage documentation, mixing time is so important, because that's what came up on this job here. When we had Tremco coming up, they were asking, what was our mixing time? Did we mix it prior? Did we add an old bucket to a new bucket? Because Tremco and any manufacturer, you know, they're going to want to you know, protect themselves first and figure out, was it the contractor that installed it incorrectly? But to our benefit, we have a Tremco rep who's on site at all times, and he's doing documentations as well as we are.
James, have you done much fluid applied?
I've done a little bit. Did the Hard Rock
Jump in.
logo on, did the Hard Rock logo on Miami Dolphin Stadium, which was pretty brilliant. So
That's awesome.
What I've noticed, really one of the biggest things that I've noticed, especially when any sort of fluid applied, it's contaminants in the air, airborne contaminants, whether it's dust, whether it's not, prepping your substrate prior to applying it. Knowing your product is one thing, but also knowing the preparation in regards to prepping the substrate you're applying it to.
And with my experience, the prep is almost different in every application.
Absolutely.
So got to read, and that's why every time I try to give you guys the spec sheets with it. You'll notice when I sent you, when we did this module, before we did it, I say in the spec sheet. I did that for a lot of reasons. I want you to be able to read it and see what we do it, familiarize yourself with the conversation that we're going to be having.
Correct.
But to look at and be able to verify some of the things we're saying. Look where it says 100% solids. Look at what it says for elongation. Again, a wealth of information there. It's going to tell you, like Frank said, you can't put this product down if you have more than 4% moisture, for instance, within your concrete. So if you're going to put it down over concrete, you better be checking the moisture of the concrete and documenting that. Especially if for instance, if your manufacturer's not, you want to be able to fall back on that. These systems can be reinforced, as I mentioned, or non-reinforced. A lot of times it has to do with what substrate you're putting it over, what warranty you bought, if you have any type of ponding condition maybe. So the fabric that we put in here tends to be either poly fleece, for instance, there on the left, or a fiberglass mat, for instance, there on the right. Anybody that's put this fleece in wet liquid knows that can be a pain in the butt at times, especially over uneven surfaces. So it's something that really you have to get better at and learn at. There's certain tricks to the trade when you put it down and stretching it in place and brooming it in. That will really help your application at the end of the day. So quality materials don't necessarily translate into a good job. You need to have surface prep right. You need to have your material application right. You need to make sure you pay attention to your cure times. Doesn't matter how good your products are, if you don't do those things right, you may not end up with the end product that you thought you were going to have. But to improve your chances of success, make sure your system's compatible with the substrate. Make sure your surface is properly prepared, as everybody's mentioned, because that tends to be the most critical factor. Make sure you got adhesion. So not only selecting the test, do an adhesion test. It's easy, and it is going to tell you what you need to know, and better yet, it can tell you something that you may not want to know, and you may want to find out later. So ensure proper application to minimize defects and maximize surface contact. Get with the manufacturer beforehand. Not only read his material, have him come out, have the discussion. Like I said, make a relationship. You don't want to get into the project, have a problem, and then call the manufacturer and say, hey, listen, come out and talk to me. I need to talk to you. Wrong time to make friends or to make acquaintance with the manufacturer's rep when you have a problem. So the more information you can get out of him and lessons learned on the front end, I think the better that you'll be. Read the specification, ask him questions about his own specification, make sure that he's having you put it down, because on some of these bigger jobs that we do, you'll notice that they'll park an inspector on the job. So they'll be there all the time. I kind of like that, rather than the guy coming once a week and then telling me I had a problem last Wednesday and now I've coated over it and I have to go back and fix it. Again, consider the surface moisture and environmental conditions. Knowing what you're putting your product over is, again, a key to success. Knowing that what substrate it is and what you need to do for it, making sure that it's clean. And as I said before, an inferior coating applied right into a good surface with good preparation tends to give you a better end product than a good product put down lousy. So again, different prep for different applications. If you're coating over metal, you guys learned in the coating process, because then nobody knew, it seemed like, what a fluoropolymer was. And I can ask people now, hey, what's a fluoropolymer? And everybody goes, oh, that's Kynar. You guys know that a fluoropolymer coating is Kynar. So you've got an idea of that. But when you're coating over Kynar, you got to be very cautious. And you got to be very cautious that you don't have another PVDF coating. So there are some tests that you can do to make sure, but again, you just got to always make sure that your surface is prepped right. Loose fasteners. Rust is the biggest thing. You'll find that primers tend to be required over rusty metal surfaces. If you don't have rusty metal, you get pretty good adhesion. If you guys, some of you I saw in your tests, I didn't put metal in your package, but I had said, hey, if you get a chance to put it over metal, put it over metal. You'll see that you get pretty good adhesion to metal that's prepped right. Your fastener holes got to be taken care of. Again, with any type of liquid applied system, whether you're putting it over an existing roof or you're putting it over a metal roof, you've always got to fix those surfaces first. You've got to make sure they're leak free, that they're dry. Those are system requirements. You can't put a coating and seal over a wet area. We talked again about oxidation in a metal roof, that you need to do something to prime that so it doesn't come back through. And again, if I can't warn you enough about being up on metal buildings, when you're on a low slope metal building and you come across these fiberglass panels that are shown here that have that has some type of fall protection over it, but those panels are very dangerous. And sometimes if you go on a coated roof, some people have coated over those panels, not knowing any better. So one thing I do is I tend to go inside on a sunny day, even if it's coated. What you'll have is on the inside of that structure, you tend to have insulation, but you won't have insulation where those old skylight panels were. So again, make sure you're doing your due diligence, because there's probably nothing more dangerous in roofing almost than one of those fiberglass skylight panels, especially if somebody's up there and doesn't realize what they're walking on. Modified bitumen, you can put it over smooth mod bit. You can put coatings over APP, over SBS. You just got to make sure you know what you're working with. Consult your manufacturer about right primer application. A lot of times primer is not needed, as we said, over an SBS or an APP system, other than the fact that asphalt's going to want to come back up through the coating. It's want to change the color of your nice white coating to yellow. So they put what's called a bleed blocker on a lot of times first to knock down, two-coat system. Your base coat's acting as a bleed blocker, but if you're just putting down a one-coat system, often we'll put down a bleed blocker first. And again, not all existing roof systems are candidates to have a coating. They're not all candidates to have a liquid applied roof system put on top. Because if I put a liquid applied system on an existing roof, that liquid applied system is only going to be stuck to the building as good as that first roof was. If that first roof doesn't meet code, my new roof doesn't meet code for uplift. And the last thing I want on my roof, especially in Florida, uplift's so important because when the wind blows, they blow off. And we've talked about uplift from the gate. Again, APPs, SBSs, great adhesion typically. Not as great over EPDM, PVC, TPO, key membranes. And again, what happens is you want to make sure these membranes are weathered when you coat them, which typically they are, because why would you coat a brand new white membrane with a 100 SRI just to get another 100 SRI out of it? It really doesn't make sense. One of the things I did do when I did put the coatings on, and I did some of the samples like you guys at home, I did them on my own roof. We were in the middle of the pandemic. I took and did temperature tests, and I just had put a white modified, and I put white coating right next to it, and the white coating was 25 degrees cooler than the white modified. So amazing what reduction in temperature you can get on the surface with a reflective coating with the high SRI. Lonnie, remember in the day we used to think aluminum coating was the thing. Aluminum coating has an SRI of 60. White brain over 100. Again, single ply, you're going to scrub it. You're going to take care of the seams. Any of these, you're going to go over anything you want to take care of the seams. Most of these systems require you to strip seams in when you put them in. Existing coatings. Most of the time, if you're buying a system coating, they're going to make you take an existing coating off unless they can identify it. One of the beauties, though, of these liquid applied systems, and I think Tremco, Frank, correct me if I'm wrong, that AlphaGuard system, it came, was that a 20-year on there, 20-year warranty?
Yeah, we're doing a 20-year on this one.
My understanding is that you have in 20 years, you have the ability to go over that AlphaGuard again and extend the warranty again without another tear off. And it doesn't count, it's a resurfacing at that point. It's not a new roof system. And that's what I was reading. So one of their selling features of these liquid applied systems is they like to say it's the last roof you'll need, but what they're not telling you is you got to come back out and put another layer or two on there, because what happens is, like with a lot of systems, over time you'll lose a little bit every year, and they'll get thinner and they'll wear out.
Yeah, they explained that during their sales presentations about the once you start to see some wear or some fabric showing through, to go back and coat it. You can coat it as many times and it does not count as another roof. So that's that is a pretty classy move on their end.
Yeah, so right out of the gate, a lot of times if you're going over an existing surface, you bypass the tear off. So you didn't do the tear off then. And if you have the ability to recondition that roof, and I'm watching liquids, closely, because let's face it, they haven't necessarily, liquid applied systems haven't been out as long as their warranties say, so to speak. So if they haven't been around that long, that's why I wasn't an early adopter to TPO. I was an early adopter to Torch. I let everybody else try stuff and work out the bugs, and then I kind of got to it as I went along. I was the last guy mopping hot in my neighborhood.
Absolutely.
Me and you, Lonnie. So three common application methods for cold applied: airless sprayer, roller, and a brush. A two-part system's a pain to spray, because you got to have it mixes at the tip. Any cross-contamination, your hose is up. My son works for a coating company. He was going to go do a job that was, I asked, how many buckets did you have? He's like, I think less than 100. And he wanted to spray it. I'm like, listen, it's easier to roll that out of a bucket than it is to pull hose and everything else. And then when you're pumping that, if you leave your pump on the ground, you've got to pump up and then across on a big building. Well, some of these single components, they're like sap, they're thick. So you're not even going to push it through a pump. And then you've got to clean out the hose. If you've got 200 foot of hose, you may waste a lot of product cleaning the hose. So again, I talked him into just rolling it, and he thanked me at the end of the day. And again, they make a lot of different fancy type roller systems to speed up the process. I love a squeegee. I'm a big squeegee guy with the right squeegee and the right notches to speed up the process, to get the original product spread out, to get it put down at the right wet mill thickness. Again, because the dry mill thickness depends on the percent solids. When it cures, again, if we can walk away with that, we're doing good. One of the things, okay, you're using a roller. Roller's good to spread it out, make sure it's even. You want to be careful near the edges. Mike MJ from Tech up in Orlando told me to make sure I told everybody that. He spent too much time cleaning up overspray outside of a building, and overspray is another reason why you want to use caution whenever you're pumping any type of fluid, because it's on a windy day, a lot of reasons. And wind, just like James had mentioned, you got to watch out for contaminants coming into the product, because again, you're making that roof on the roof, so to speak. Again, when you're putting down a solvent-based product, make sure you're using solvent-based roller covers. Some people look, huh? They do make solvent-based roller covers. They're going to last longer, etc. That works great with a solvent-based single-component product. A solvent-based or a solvent or a two-component product, forget it. The stuff's going to get hard on the roller, and you're going to throw the roller cover away anyway. So you don't have to really worry about wearing them out. You using regular roller covers on the job, Frank, at the courthouse?
Yes.
Yeah, that's what I said. Because with a two-component, they get hard in 15 minutes, and you throw them away anyway. So that's why you're using things like chip brushes. You're not using, you're using inexpensive stuff that you're going to use one time, throw away. Brush or squeegee. Oh, so you're putting down these products. Anytime you're putting down a two-coat coating system, liquid applied roofing, and you want to go one direction on your first pass, and then you want to go the other direction on your second pass. You want to cross-hatch, okay? You don't want to go north-south on your first one, north-south on your second one. Again, you always want to cross-hatch them. That's why I like coating systems, too. The base coat's slightly different color than the top coat. Okay, so that you can tell that you've got good coverage for both coating systems. Talked about reinforcements, multiple coats. Again, watch your cure times, very specific. If you don't make them, you may have to apply a primer. PMMA, you may have to sand it, okay? So you got to really, because what happens is that surface gets so solid that it won't accept, the new coating won't bond to it. Again, you got to watch out for over application. If your product says 32 wet mils, shoot somewhere between 32 and 36. Don't put it too heavy. Don't put it on too light. What you're doing is you're impacting your cure times. And Frank, I'm going to have you talk to that, because I'm going to get it. The other big thing I want to have carried away here is surface prep as far as concrete goes, because we haven't talked about that. And I think it's huge depending on what type of product that you're putting on concrete. So I'm going to get to that right here in a minute. So some considerations to make sure you have your correct DFT. DFT, dry film thickness. So you want to make sure you know your wet film thickness of each application. You want to make sure you know the product's percent solids. If you've got those two pieces of information, there should be no reason they shouldn't be able to calculate your intended dry film thicknesses. You want to make sure your gritting is right on the roof. Because one of the things I do is I make sure I grit it right first, based on the coverage. And if you guys remember, we had the conversation, and that Tremco product that we talked about and that we're using, the Alpha Guard, when you mix it, it comes in a 5-gallon bucket. There's 3 gallons, just over 3 gallons of product in the base coat, and then you put 1 gallon in it. So at the end of the day, your 5-gallon bucket has 4 gallons of product in it. So if you don't know, if you look at a 5-gallon bucket and just think, oh, it's 5 gallons of material, you're dead wrong. And your product's too thin because you've gridded the roof for 5 gallons thinking that there's 5 gallons in the bucket, but you're short. So you're 20% short on your coverage.
And that's also a good reason why you're going to do a mill gauge test quite often when you're putting down that liquid applied.
And you may find out, yeah, you may find out, whoops, because now you just switched to top coat, and the top coat, Frank, of that same system has less than 4 gallons in the bucket. I think it's 3 and change in the top coat. And Lonnie, you and me talked about that on a previous webinar, the differences in that, and I was trying to figure it out, and I was thinking, well, maybe the top coat can go on thinner, which it does if you have a mat, it ends up going on thinner than the base coat. But I was trying to figure out why is there less product, and I think when we had Daniel from GAF on, he kind of alluded to it And it had to do with, I think, percent solids by weight in the bucket. So a little bit complicated, but again, always, and again, it's on the data sheets. It's on the data sheet. So always read all the data sheets before you start. Monitoring wet finish thickness we talked about, and always consult the manufacturer.
Why you open it for?
Some pictures, and again, here's the bucket on the left before we mix it. We're pouring the B component catalyst into it. Hold on, somebody's open in the background.
So you want to put stuff in there? Yeah. Why you should wait till tomorrow to do all that.
Sorry, I had to mute everybody. Okay, back live. Had to get rid of that sound, sorry. So here's just a picture on the job, doing that Tremco job. You'll notice in the picture on the left, we're getting ready to mix the two components, the A and the B together. The base coat is already down, okay? And you can see that there's stripping on top of the seam. So there's what's 3-inch poly you put on those seams, Frank?
Yes.
And that's fairly typical?
Correct.
And you do that in the field and on the flashing?
Yep.
Flashing laps. So then when they mix it, look at, that's all the product that's in the bucket. If you can see, that's short of 5 gallons. So there's no doubt about it. And then the picture on the right is Frank actually timing the mixing process. Okay, so again, critical information to record on a daily basis. Here's some pictures of just some grid setups, and we talked about how to grid, and it has to do with what's your coverage rate, how many gallons per square do you need? Well, that's in the specifications. It's in the general spec. It's going to tell you if you want a 10-year system, you may need, or a 20-year system as opposed to a 10, you may need to put more millage down. So again, reading the spec and knowing what warranty you have is key to success on these projects. And then taking a good look at the contract, making sure that you have a look at the contract if you're in charge of the job to know what your client expects of you. I took this picture just because I was noticing these buckets turned upside down. You know, it'd probably be a solvent-based product, probably have a lower percent solids in it. And what these guys did, they turned the bucket down the night before, they turn it over. What that does, it lets all those solids that were at the bottom, they come to the top. So when they flip it back over in the morning, mixing tends to be a little bit easier. Okay. This is in your package, is just some grid work on how to figure out gridding. But it's good to ask questions, do the math a few times, make sure you know how much is in your bucket. And then I tend to set my grids up based on the job. You know, if I have a thin roof, I measure how wide it is and I multiply what do I need to get the 200 square feet per one bucket. So if I covered 200 square feet with one 5-gallon bucket, does everybody realize that my coverage rate is 2.5 gallons per square? Because 2.5 plus 2.5 gives me 5 gallons. So in that one bucket, we'll do 200 square feet at 2.5 gallons per square. Some of the things, Frank, can you talk to these quick? Because I know you're living it right now. I know that you have surface temperature requirements plus air temperature requirements to apply. And again, some of these, if I'm putting down that urethane that you're putting down, I think 40 degrees is my limit. But one of the attractions with these other systems, these PMMAs and these Puma systems, is that they can go on as low as I think 0 degrees. Not something that we have to worry about in Florida too often.
Correct.
Where you're at, James, in Orlando. But if you could speak to some of these temperature, humidity, and then on the next page, I think I have dew point and another one. So go ahead.
James, you want to go ahead?
Speak about necessarily the dew points and the temperatures. Is that what you're referring to?
Yeah, I just like any experience with that.
Well, yeah, I mean, you know, there's a lot of things that go into surface temperature. One is the humidity, the air quality, different things that affect. So you definitely want to know, you know, just different components in regards to that. What are the limitations? You know, not only are there limitations on minimum requirements, but a lot of these products have maximum temperatures as well and maximum humidity rates, because it's going to affect how the stuff adheres and how it blends, and also cure times, different things to that effect. So surface temperature, and once again, as it mentions, humidity is a big part of that surface temperature. So no different than walking outside yourself. The temperature is one thing, but the feel like temperature is another. You know what I mean? And that comes from that humidity. So it pays to do your homework on your product, for one, and to know what those limitations are.
And again, being in South Florida, I think we've got to be more cautious of the upper end limits than the lower end limits. I mean, if you talk about putting on a coating product on a metal surface in the middle of summer, I don't see anything to exceed the 120-degree limit. So time of day matters. But if I'm putting stuff on that metal, everybody knows you get up on a metal roof in the morning and it's probably got dew on it. So you've got to wait till that cures off, not only in the field, but in the seams before you can even apply. So humidity, temperature, dew point, surface temperature, moisture content was huge. We talked about moisture content if I'm going direct to the substrate, specifically in concrete applications. And what we're finding and what we're learning on this job, Frank, correct me if I'm wrong, is it doesn't matter the age of the concrete, because concrete cures and concrete takes time to cure. So it might not reach its full strength for a month. And it might not have the moisture content that goes out of it, because concrete cures by hydration. So it's a chemical reaction. So over time, the moisture leaches out. The concrete gets harder over time until it reaches its ultimate strength, its design strength. So we're finding out, though, that certain conditions, you got conditions that in the buildings that produce things like condensation, et cetera, which are putting, and there's moisture in the air, and concrete is porous. So concrete will actually absorb the moisture. So getting that concrete to an acceptable moisture level, and the key, I think, and one of the things I think we're learning is, number one, do your due diligence up front and check it. And if you don't have the moisture content that you need up front, ask the question right away and say, what do I do? And put the onus then back on the manufacturer. They wrote the specification for the job. So put the onus back on the manufacturer to say, listen, what do you recommend that I do? So that way, when they give you a specific set of instructions and you document that you followed them exactly, and God forbid you get another problem related maybe to that surface moisture that you found out in the beginning because you did the test that you needed to do, they're responsible and not you for that end product.
Good point. I found too that when out in Seattle where I'm from, we did a lot of our coatings, and we figured out that when the dew point's dropping, it tends to, when you're, for example, priming concrete, the concrete tends to draw in the primer more acceptable when a dropping dew point and temperature. That's what I found out. That seems to, benefit as far as the lowering of dew point. But that out here in Florida, that's not going to happen, because it's always rising. From the moment you step on that roof, it's always getting hotter and more higher dew point.
I got 5 minutes left, and I'm over my budget, but I thought this would, again, I apologize for missing these points last week and the confusion. I wanted to try to deliver this message one more time, and I think it's been good, like I say, hitting on all the main points of this liquid, because it can be a problem if it's not done right. So we talked about different substrates that you can put it over: concrete, insulation board, base sheets. A lot of time we just put a base sheet down over something and then apply the system over it. So I can put a base to, say, a lightweight concrete and then put the system on top of the base sheet. And existing coatings, I may be able to go with an existing coating, but I got to know what it is. But whenever I'm doing concrete, 9 times out of 10, they're going to make you take off the existing coating that's there, especially if it's not theirs and they don't know what it is. They're gonna have you take it off. Well, each one of these, depending on what you're doing and what type of sealing or coating, liquid applied system you're putting on the concrete, somewhere in that specification is going to tell you what level of prep that concrete gets. It's critical. It's critical, and we'll talk about it. So that tends to be, when I'm going on a job that I'm going to coat over a concrete deck, that's one of the first questions I ask. Well, for this product, what prep are you looking for? And not only what prep, when they tell me, oh, I'm looking for a 4 to a 6, I'm saying what works best. So if they tell me 4 to 6, I might shoot for a 5. Well, if I know what level of concrete prep I need, that's going to tell me what machine I need to prep the concrete. So I can't just bring out a scarifier because I need to take the coating off, or a shot blaster. If I need a rougher surface, I've got to know that the machine that I bring out and that I rent is going to give me the surface that I need, because when I get ready to put the coating on, I'm going to look at the manufacturer and say, sign off on my surface prep. And if they say it's too rough, I got a problem. If they say it's too smooth, I got a problem. So you can strip it, you can acid etch it, you can use a scraper. Those are going to give me smooth surfaces. Cup grinder, going to give me a smooth surface. I get into scarifying, I'm going to get a rougher surface. Shot blasting. Mechanical rated writing scraper, one of the best things I've ever used to do these jobs. Because at the end of the day, when you're prepping concrete, you want to get something called a CSP number, concrete surface prep. And if you'll look at this slide, the different, and I'll make sure, I don't know if I've said this, I haven't sent this revised review out, but I think you have all this information in the one that I did send out last week. So if I'm putting down a sealer, a clear penetrating sealer, I need a smooth concrete. So I need a 1 or a 2. But depending on what I'm doing, and if I'm putting down, I think the system that you're putting down, 2 layers, 100% solids product, Frank, 32 mils in application. So I'm going to say that your end product's probably somewhere around a 64 mil.
Well, total is 96.
96, was that with the scrim, or with the primer coat? How is that?
Primer, base, and top coat.
Primer, base, and top. So you get to 90. So you'd be in this self-leveling topping area, of which my understanding is when I read that specification, it did call for somewhere between a 4 to a 6, correct?
Yeah, we're at the high end of a 6 on that.
Okay, and again, I think that may be, correct me if I'm wrong, some of the challenges we may be having is if I put down a self-leveling topping, and that's just what it's going to do, it's going to find its own level. But if I put it on a surface that's really rough, that means where its high points is going to be real thin, but where there's a low point, it's going to be real thick. I don't need to tell you that I'll have more millage, more wet mills in the low point, so it's going to take longer to cure. So what's going to happen is my deck's going to have an uneven cure. I'm going to have, all my high points are going to be cured out too much. All my low points are going to not be cured enough. So again, that's one of the keys to having the right surface prep. Again, I talk about mills every time because I want you to understand mills. Even last week when I talked about mills, some of us are still getting confused with millimeter. It has nothing to do with the metric system. A mil is 1/1000th of an inch. So a 45 mil sheet that we use would be 0.045 of an inch. So just for relativity, if I say here self-leveling topping at 1/8 of an inch, 1/8 of an inch is 0.125 of an inch. So that's 125 mils. So that's like one of the thickest fleece bag sheets that we put down would be about the same thickness. I want you guys to know and be thinking of that. We use 040 metal. Know what the thickness of that is, about a credit card. Okay, so again, just making sure that we're working with the right math measurements all the time. Again, I sent you video on surface preps, guide to surface prep, so you understand what the CSP is. That's going to be measured by the distance between the highs and the low. Again, CSP rating for the product, it tells you what they're looking for. It tells you in your spec what the moisture content is, okay? Critical that you read the documents that go with product. This isn't Christmas time. Don't put it together by looking at the picture. Okay, we talked about mixing. Don't need to hit that again. Different products, again, for when we do our labs, this is what we're using. Okay, talked about our considerations to make sure that we're putting down a quality job. And a lot of times we're using these products in these conditions right here, planters. Not easy work. Tight spaces, confined spaces, got to be clean. We just took dirt out of them maybe if we're doing a redo. So again, planters, a trick amongst themselves. We'll take a harder look at this going forward when we talk a little bit more about vegetative systems, but with these systems, not only do you put in PMMA is a common one that goes in there, these Puma systems are common, the two-part urethanes are common that go in these planters also, but you need to then put root guards in there. You need drainage mats. You need to make sure the bottoms are sloped. So planters are a roof amongst themselves. Talked about weather conditions. You can't put a lot of these products down before you have rain. But what is critical to know, and our study mentioned it last time, was the difference between an acrylic that doesn't skim over necessarily, and you put it down and you get rain 2 hours later, don't leave because you got to clean the parking lot, because it's all going to be in the parking lot. That all the stuff you put on the roof is going to run down, going to come down the downspout in the back, and be in the parking lot. But some of these urethanes, especially the two components, will skin over in an hour. What do you get on a skim time with that two component out there, Frank, to where you're rain ready?
3 hours.
Okay, yeah. I mean, real quick. And some of these PMMAs are down to like 45 minutes. They cure so fast. I talked a little bit about PEL. This is a safety term you guys should know about. It has to do with a lot of things, but even when you're using a tool that makes noise, you have a PEL. That's your personal exposure limit. So know what it is, especially anytime you're working on these coatings. We talk about VOCs. We talk about VOCs all the time, volatile organic compounds. They're probably the stuff, because they're named volatile, that you don't want to be breathing in. Okay, so again, you'll have a PEL limit. You need to know, do I need a respirator? Look at your product documentation, because it's going to tell you that. You look at your SDS, your safety data sheet, and you see a picture of some lungs with an X over it. You know it's not good to breathe. So again, make sure that you have this information available to you on the job. Make sure you look at it and understand it. Make sure you ask questions when you need to. With these systems, you can put walk pads down. So what you're going to do is you're going to just put a little more product on top. Typically, they use a different color, so you know where to walk. And you broadcast your product, your aggregate in your wet product. Do you have to back roll this one, Frank?
Yeah, we did. They had to back roll it because that aggregate's really thick, and it had to get absorbed into the top coat.
So read your product data. Some of it you back roll in, some of you don't back roll in. Okay, depends on the product. What else about walk pads? One of the things I do whenever I do a walk pad layout, before I start to do the roof, I go on the roof and I try to take a look at where all the walk paths are, because it's human nature. They're going to take the shortest distance. So if you put a path somewhere else besides where your current paths are, nobody's going to use it. Just because it's painted don't mean they're not going to take the shortest distance between two places. Again, so these are many of these systems that we're talking about now, a liquid applied membrane roof. They put dirt and plants on top of them. They put pavers on top of them. You walk right on them. Maybe they pour concrete right on top of them. I did a job to pour concrete right on top of the system. So it's trapped between two slabs. Sika, one of the companies that make this, they make an electrified mat that goes in there. So when you put your roof down, you put this mat in there, and what happens is you bury it in the system. They can go back, they have a machine that will tell them where you have a leak in the future. So you don't have to pull up all the concrete to find out where your leak is. But when you put overburden, that's all called overburden. When you put that on top of there, you better make sure that your system doesn't leak, because you don't want to have to tear that product out just to do the repair and then turn around and put all that product back in. Somebody may have tile on their balcony. It becomes a real pain sometime. So what we do is we do flood tests. I don't like the one where you just run, there's two types. One you just run water over, and one you put water on there, you plug the drain, and you leave it overnight. I like that one. You got to make sure, though, that somebody tells you how deep the water should be. It should never be more than 2 inches, really, because you want to overload the structure and collapse it. I'm not going into the trade terms. I'm going to end this show, not the whole show. Don't get excited on me. And I'm going to go straight into EPDM, because we have a time crunch, and I want to make sure I cover EPDM also. So thank you for being part of the liquid applied membrane review, everybody. But Now we're hitting today's meat and potatoes. So we're going to talk about thermoset membrane roofing. We're in South Florida. I don't blame anybody if they really don't know what I'm talking about, okay? Because we don't use it down here so much in South Florida. James, what about Orlando? Are they putting it down anywhere up there that you know of right now?
No, they're not putting it down now. I mean, there's some existing buildings essentially that still have it lagged over from, but it's never had a large presence down here, or even in Florida in general. Jacksonville market either. You know, the further north you go, being Atlanta, Charlotte, a lot of those areas, it becomes more, you know, dominant. You know, it's just because of the cost. It's just mainly because of the cost.
As it's things, you hit on like 4 or 5, in one sentence, you hit on like 4 or 5 great things of the program. One, EPDM, one of the most economical roof systems to put down.
Mm-hmm.
And applies in general tend to be more economical because the nature of single ply, one layer. So if I have to put down 3 layers of roofing with hot in between each layer, you can see that the labor component is more. Some of these sheets are huge. I can get a sheet, you know, a lot of them are you know, 200 is pretty common, I think. So you're kicking out a lot of roof in a day. So they go down fast. They're economical. The price of the rubber itself isn't that much. You have a 20-foot wide sheet. Well, a lot of labor goes into seaming. If I'm putting down 10-foot wide sheets of TPO, that's twice as many seams that I got to deal with. But as James said, they're not that prevalent in Florida in general. Why? We get a lot of heat. So they tend to be black. I mean, they do make a white EPDM, not as, I don't, you know, it's not, it just seems like black is what they use, because where they use it, a lot of times they're trying to do just the opposite that we're trying to do in South Florida. They're trying to capture the heat and warm the building in Chicago in the wintertime, as opposed to reflecting the sun in Chicago in the summer. They care more, because to generate heat costs more money than to generate air conditioning. So they're concerned with capturing the heat in other markets. So it's another reason that you may see it in a lot of other markets than down here. We get more rain in South Florida than anywhere else pretty much in the country. These seams are these are glued seams. Thermoplastics are heat welded and fused together. These membranes, you can't fuse them together. You put heat to them, they're going to burn before they join together. You have 2 pieces of burned membrane, okay? You glue them together. They're applied, they're seamed with glue, typically, or a pressure-sensitive type of flashing, which has glue on it. So, but that's the nature of the thermoset membrane. All right, whoever is careless with the truth in small matters cannot be trusted with important matters. Albert Einstein, pretty smart guy. Maybe it still applies. One of the things I like to say, always lesson of the day, I picked this one because I've gone through a lot now in 2 years. And this one hit me because I find it out every day that life never gets simpler.
Clay.
It gets better.
Hey, Clay, we
Yes,
can't
sir.
see your PowerPoint.
Say what?
We can't see your PowerPoint. The only thing that we can see is the common code in straight turns, the last piece that you
All
left.
right, hold on. Thank you.
Got to share it.
Well, I know, I appreciate that, because, you know, maybe somebody else would have let me get through. Did it go away, Ramon? Hold on.
Yes, Clay, but now
Okay,
it's your
so
face.
let me try again. How about now?
Yes,
You got it? You got it back?
yes, you're good now.
Okay. So what you missed was the cover slide, which wasn't much, okay? And then I have my saying from Albert Einstein: whoever is careless with the truth in small matters cannot be trusted with important. And life never gets simpler. But again, doesn't mean it won't get better, but it doesn't get simpler. You know, we start out now, we're by ourselves, we got ourselves to watch out. Then our family gets bigger, and then maybe we got kids. Don't get no simpler. And then our kids have kids. Then it gets simpler. So for the thermoset, resources, what I did is I pulled the two books from the program, NRCA Membrane Roof Systems, Guidelines for Single-Ply Membrane Systems, and then Quality Control and Assurance Guidelines for the Application of Membrane Roof Systems. I took the Thermoset sections out of both of these. James, you still with us? We lost your picture.
Yeah, no, I'm still here.
Just making sure. Thermoset Membrane Module reviews EPDM installation, as it is the predominant thermoset in the marketplace. Are there other ones? Still around maybe, but
Hypalon.
it is the predominant. Sir, what?
Hypalon's still around. That's a thermoset.
And I mean, is that a PIB, Frank?
No, it's a PVC. It's around still. You're going to come across it, but EPDM is generally the only thermoset out there, or one of them.
So we want to gain an understanding in thermoset single-ply roof systems, understand the primary difference between thermoset and thermoplastic membranes. And you guys, I'm going to unmute you in a minute because I got an opportunity for an Uber Eats coming up again. Elijah, you got the first one. Determine suitable substrates for EPDM. And again, when I put this together, I'm only going to focus on the differences between the thermoset and thermoplastic, because we've looked at PVCs, we've looked at TPOs, we've installed them, we've done the details. And the details are really kind of the big difference between EPDM and TPO as far as installation practices go. So that's what we'll take a look at. I mean, material properties, yes. Determine suitable substrates, review common flashing details, and in the lab, we're going to install an EPDM roof system. So we'll butterfly the membrane back. We'll put our contact cement on both sides of the membrane. We'll flop it back into place. We'll lay the seam out. We'll put the primer, the seam tape, and then we'll roll it together. And again, like anything else, when you saw the videos, you understand the importance of the contact. Anything we do in roofing, that contact is key for proper bond and proper seal. So when they put the seam tape in, they're always rolling it in, they're always rolling the seams in. When we put the membrane down and we glue it together, we're gluing it in, we're making sure, again, we have good contact because we want to have good adhesion. So again, these terms you'll see keep repeating themselves and repeating themselves throughout the whole program, and hopefully I'll come back to them on the last day. So real quick, the majority of low slopes systems in use in North America serve as weatherproof coverings for roof assemblies. Roof membrane protects the underlying building's components such as insulation, roof deck, and the building from water entry. Most low slope roof membranes have two principal components, a weatherproofing layer and layers of reinforcement. Weatherproofing component is the most important element within a roof because it keeps the water out. In single-ply roof membranes, the weatherproofing component is the thermoplastic or thermoset polymers. Again, so thermoset is a polymer. We've talked about polymers throughout the program. The reinforcement adds strength, puncture resistant, and dimensional stability. In single-ply roof membranes, it's typically fiberglass or polyester we talked about. However, some types of single-ply membranes, such as unreinforced EPDM, don't use reinforcement. It's unreinforced. Two types of principal materials used in construction of single-ply, like I said, thermoset polymers and thermoplastic sheets. Terms describe the materials' different behaviors on heating. And it's due to their molecular arrangement. So I'm a roofer. I'm not going to get into the chemistry involved in it for the simple fact that I don't know it. For thermoset roof membranes, the material's principal polymers are chemically cross-linked. This chemical cross-linking of thermoset membranes means that once the sheet is cured, and if you ever hear the word vulcanized, that means cured. It doesn't have anything to do with Spock. You will know who Spock is, okay? Vulcanized, okay, it's a cured sheet. It can't be softened and bonded together. So I can't melt it and join it with another piece of EPDM. That means it's vulcanized. It's already cured, okay? TPO, PVC, key membranes, thermoplastics, different story, okay? I heat them and I heat them to the right temperature, and I join them together, and that bond is pretty much better than the original membrane, okay? So a key, and that's one of the things why thermoplastics are so much more successful down here in South Florida, where we have so much rain and so much water on these low slope roofs that it causes problems with these glued seams of the thermosets. So thermoset materials used in construction of single-ply membranes such as EPDM, which is ethylene, propylene, diene, terpolymer. Nothing is going to be in a quiz on that, I don't think. Our manufacturer is cured or vulcanized or partially cured, intended to fully cure on the roof. So there are thermoset membranes, okay? Let me get all my participants and unmute all. Thought I could do it all at once. Can you guys unmute yourselves? Because can anybody tell me the 3 most common types of thermoplastic membranes for Uber Eats?
You just showed it.
I know. Well, I didn't take the prize away. Anyone pay attention for Uber Eats, the 3 most common types of thermoplastic membranes that we use?
EPDM, PVC,
TPO.
TPO.
All right, Ramon, you're going to have to give Edgar a bite because I think he answered one of them for you, but I think you knew it anyway. He just jumped in there, but you're correct. And I threw that in there to try to throw everybody off because we're talking thermosets and I wanted to throw the thermoplastics in there. But yes, so you just understand the difference. These are the thermoplastics, TPO, PVC, and key. Again, sometimes we've looked at thermoplastics, we welded them before, we've done our best to tell them apart, okay? And the guys know that when we were doing Rhino Bond down here in South Florida, I pulled some membrane off the rack, it happened to be PVC, yet we had gold plates for Rhino Bond and we couldn't make it stick. So again, knowing the material you have and being able to identify it is key, and we talked about things to be able to identify different types of thermoplastics. So currently, ethylene, propylene, diene, terpolymer, EPDM, and the M comes because it's an M-class rubber. But again, this is real common. What product do you know of that looks a lot like EPDM roofing? What about the inner tube in your car tire?
Yeah, tires.
Your tires. So guess who makes EPDM roofing? Firestone.
Firestone.
Firestone, yeah.
What else does Firestone make?
Tires.
Dude, you see what I'm saying? So same basics. So when you think of EPDM, and James, correct me if I'm wrong. I mean, I think of it as just black rubber.
No, it's very much like an inner tube, just a little bit thicker. Very, very much. I mean, even patching it. If you were a kid back when I was a kid, anyways, they had those little patching kits, and you would literally patch it with an adhesive and a primer, and you'd rough it up and apply pressure to it. It's pretty much the same exact principles.
Man, I'm bad with this, Frank. So what does the EPDM stand for?
Are you asking me?
It stands for ethylene propylene.
You and James don't get the Uber Eats, sorry. Anybody, EPDM?
I know what it stands for. It's ethylene.
I'll give you Uber Eats for trying to say it.
Clay, can you hear me?
Baleen propylene.
Yeah, ethylene propylene diene terpolymer. I can pronounce it with.
All right, Ramon, I'm gonna let, just because our study came on the thing and tried to steal it from you and you already got one, I'll let him have it, but it's ethylene, propylene, diene, terpolymer. Here's the main thing for me in doing what I'm doing. I want you guys to know that if you see that word written out, ethylene, propylene, I don't need to be able to pronounce it. I just want you to know that they're talking about EPDM. if you see it. So, rocking and rolling. Let me check my time because I got to get everybody out of here on time. EPDM, so it's synthetic rubber, elastomeric compound. So if it's an elastomeric, what's that tell me about it? Anybody?
Stretches.
It stretches. Excellent. Excellent. It stretches. And not only does it stretch, you can stretch it like if you have a 3-inch piece, you can probably stretch it to 6 inches. It stretches 100%. Okay, so that's one of the characteristics. So again, don't need to know all this chemical stuff in here, but EPDM generally is manufactured as vulcanized, which I said cured, sheet, but also can be formulated and produced in a non-vulcanized or uncured state, which usually is used as a sheet flashing material for detailing. So James, the details that I sent out for the guys to take a look at, if you had a chance, was like, for instance, the inside and outside corner for a curb, for Firestone, or for a seam, not a seam, but for a corner, tends to use the uncured, correct?
Correct.
And not only would it be
And also T-patches as well, normally.
uncured, and again, excellent point, because I put that in at the end when I was putting the program together. T-patches, this is a single ply, so wherever you have a T-joint, and everybody knows T-joints because most everybody here is a production roofer and does TPO, or you're a repair guy and you go out there and put T-patches on when production forgets to put them on. You follow them around and do it. You know it's the same principle. You need the T-patch as a secondary method or a primary method to keep water away from that joint there where the membrane goes together. We have the opportunity for water to wick in that hole. Now, EPDM also comes reinforced and non-reinforced. So, of course, correct me if I'm wrong, but I gotta assume that the uncured would always be unreinforced because I'd have to be able to form it, right, guys?
Yes.
Again, I didn't do it. I put a few pieces on in my life, mostly patches.
Mm-hmm. And that's most of what guys are going to be doing. I mean, you're not going to see a whole lot of new installs. You're just not going to see a whole lot more. Not down here in Florida, anyways.
Talk to me about those new installs. So, and let me go to the next, because I might have it on one of these. EPM membranes exhibit good resistance to ozone, ultraviolet, and UVs. Some of these systems, and what as part of putting this lesson together, what I learned, came out, roughly in the 70s. Frank, I'll ask you, maybe you're a little older than James, I don't know, but
Thanks.
gray in his beard, it just depends if you got kids, I guess, the amount of gray you got. But around the 70s, when did EPDM really start taking hold? You guys know?
No, it was in the 70s. You know, that's when it really took off during the oil crisis that they were having. That's where it kind of started, was back then. So yeah, it's been around for a long time.
And what I hear is that some of the roofs, I mean, up to 50 years of service, if it's put on right, in the right environment, the right slope. So long-lasting system, but you get a small hole in it, difficult to repair, or difficult to find that hole a lot of times is what I used to find, I think, on a real small puncture.
Actually, I like to, I mean, it tends to, when you're walking down an EPDM roof looking for a puncture, when you find a puncture, it's generally darker in color because it's drawing up the heat from the insulation. So it's kind of a telltale sign that there's the puncture right there. It helps out. It makes it easier to find those punctures.
Yeah. And a lot of times what you'll see out there is that it has a tendency of shrinking through age. So once you do get a puncture, it usually turns into a split, which turns into a large gash. So, you know, they're not, I think they're probably easier to find holes in EPDM than TPO.
Hey, Clay, just a real quick thing. It was kind of funny that we're talking about this because James and I were on this Port of Manatee. They had it down at the terminals. They had we were called to go out and look at this roof. They had a blow off, and it was an EPDM blow off. And this roof was, I don't know, what do you say, James, 30 to 40 years old? It was a,
Yeah, probably 30 to 40 years old.
and it was a fully adhered system at one point, but the facer off the polyiso separated, so the whole roof was just floating. It was floating, but it was so brittle. It was so brittle when you walk on it, you could almost puncture a hole on this thing. It was bad.
Yeah.
EPDM resistance to some acids, alkalis, oxygenated solvents such as ketones, esters, and alcohols. In the right environment, I said EPDM can provide some long service life, and with an economical initial installation, economics tends to be one of the main drivers, I think, in installing one of these type of roof systems. However, exposure to aromatic, halogenated, and aliphatic solvents, as well as animal and vegetable oils and petroleum-based products, should be avoided to prevent membrane swelling and distortion. And so many times when you have these products and you go out there and you see somebody that didn't quite know what they were doing, and they went up on an EPDM roof and they fixed it with bull. And bull's a petroleum-based product. And it had made the membrane kind of wrinkle and almost look like it grew, which is in the membrane swelling and distortion that I have here. You realize that they're just not compatible. So when this said, of examples of aliphatic solvents, I asked myself, well, what the heck's an aliphatic solvent? Just like I do when I'm putting a lot of these programs together. If I have a question and I'm wondering what it is, I bring it to you guys. I want you to understand the definition of it too. So an aliphatic solvent, gasoline and kerosene are examples of those. And I mentioned to Frank, back in the day, I used to use gasoline to clean. Is what I was taught when I used to do repairs. And James, I don't know how far back you go, or if you're familiar with that application. But I used to use gasoline all the time to clean it. I thought I was doing the right thing. And an aromatic solvent it has things like naphtha, toluene, and xylene. And again, these are all solvents. And if you'll notice, we've talked about most of these solvents before. These are solvents that are in your roofing products that they'll cut the roofing products with to make them flow, whether it be an asphalt-based product, whether it be a polymer. A lot of them have these solvents in them, okay? So they tend to lend themselves to the cure, lend themselves to cleanup. And Jason is 100% correct. So thank you. And don't hesitate to jump on here and just start talking, Jay. He talks about a blower and using a blower to be able to, you see the dust fly up and then patch the holes. So a blower, and what I'd heard before, you're having trouble finding one and is mechanically fastened, you can put a little soapy water solution on it. You got a hole nearby. I've known people that put the blower in the roof, and wherever the air comes back up out of the roof is where you got your hole, especially if you've got an area where you got a whole bunch of little holes, maybe after a storm where something's rolled across the roof. And you can't do it with an adhered system, but just little tricks of the trade. So EPDM sheets range in thickness 45 to 120. Guys, what are the most common that Frank or James, what are the most common that you installed or see in the field as far as the
60 mils?
60?
45 and 60. What you got
45.
right here, 45 and 60 is pretty much the standard. At least anything mule hide. I mean, that's usually it's 60 though, because it's ballasted.
Yeah, they got the 90 mil. The 90 mil gives a 30-year warranty though.
Yeah.
And then, okay, so something to think about. So if you want a warranty dependent, again, we talked about that with the liquids. If you guys notice, thicker material, longer warranty. So if you're looking for looking for a long-term installation in the right conditions, a lot of times buying that extra material, most of you, 2/3 of your job tends to be labor. So a little bit on the material side to get another 10 years life out of the installation may be a bet as a long-term owner that you'd want to place. Frank, also, when I looked at this, it kind of said that when you're working with it, the 90 mil lays down really nice too. I don't know if that's true, but that was one thing it just said when I was reading it, that really lays down good in all installations.
Yeah, I'm not really familiar with 90 mil. I generally work with the 45 and the 60, not the 90. So I don't have no input on how it lays down. I'm sure it does. It's a lot heavier.
I'm sure it's heavier. That's harder to move. That's what I was gonna say. But some of these sheets come up to 50 feet wide, to eliminate seams and stuff. So, in special order, but if you have that, I'm telling you what, you gotta, number one, make sure you put it in the right place with a crane, because you're not gonna move it up on the roof. You may need a crane to help you unroll it at times too, to get it going. You probably, if you can, want to put it on the high side so you're always rolling downhill as opposed to uphill or across the roof, so to speak, depending on the layout of your sheets. EPDM sheets, you can get them reinforced and non-reinforced. So not having done a lot of EPDM, I'm going to ask you guys, I'm thinking just in my mind, if I'm going to mechanically fasten it, I need a reinforced sheet because I want to scrim in it. And I don't want my fasteners pulling out of a non-reinforced sheet. It doesn't make sense. But if I have a ballasted system or an adhered system, I would think I could use a non-reinforced sheet. I would think maybe I get better movement with a non. Why would I want non-reinforced over reinforced? And in what applications is my question.
Well, the unreinforced will go, just like you said, when it's a ballasted system and or it's a fully adhered system is where you're going to run it. Reinforced is, like you said, is when you mechanically attach it for that reinforcement along the plate seams.
Any other, and I guess if you didn't have it fully adhered, which would be kind of attached everywhere, or ballasted, which would be held down everywhere, then you'd want to have reinforcement. And let me tell you what, these EPDM, I've gone in Florida is unique. You guys know that because we have, especially down here, James, I don't know how familiar you are with South Florida, but we operate under the HVHZ, the High Velocity Hurricane Zone Code. But all kinds of different uplift requirements. I was called once to a roof and I had to go. I used to work for a management company. I went to Alabama. They said, hey, we got a problem with our roof. I guess at one point in time it was ballasted and there was no ballast anymore. They took the ballast off. But these roofs are only secured at the perimeter. There's no fasteners on a ballasted roof in the middle of the roof. What they do is they put round, you guys from South Florida that haven't seen it, they put round stones up there. And they're big round stones because you got to walk on them and they got to hold the roof down, but you don't want them to puncture the roof. So they're not like the P-rock gravel we embed down here in our hot systems and that type of thing. They're not angular. They're smooth. And their primary purpose is to hold the roof down. We don't have them in South Florida because when the wind blows, they go flying into the building next door and take all the windows out. That's why we don't have them down here. But this roof, and I was on this roof when the wind was blowing 45 or 50 miles an hour. And this roof had 3-foot waves on it. I don't know, James, if you've ever seen it anywhere, but the wind was blowing this roof and there were literally waves going across the roof. And the problem was it complained about the leaks because it was lifting the stacks right off the roof. And then the roof would go back down and it would cut a hole in the roof right next to the old stack. So interesting, just the different applications in this ballasted system. You need to make sure, too, when you're using ballast that your structure can hold it. Because if I'm not mistaken, that ballast is about 10 pounds per square foot.
Yeah,
It's 10 pounds per square foot. They even used on ballasted system, they have perimeter and corner fastening for the ballasted roof. It's not fastening, but you add more weight to your corners and along your perimeters, whether it's 10 pounds for your field and 15 in your corners and your perimeters.
So just like we put enhancements on a mechanically attached system.
Yes, sir. Same thing.
Yeah, you got more rock in the corners, more along the perimeter, and less out in the middle of the roof.
Yes.
correct.
And then over time, I guess, people go up there and disturb it. It gets all over the place, and who knows what you got after a few years. And when you do work with that, just like if you come up on a built-up roof and you had to repair it, and you had to scrape all the gravel back, it's a little easier, but you do have to take all the rock back off the area, do the repair work, and then put the rock back into that area. That ballasted system. Okay. Oh, and then they also make another sheet that's fleece back. So it's got a polyester fleece on the back of it. Anybody ever install that?
I have
I
not.
have not.
Yeah. But again, fleece may be what we're gluing to. It may be what we need to separate that roof system from another roof system. So we're going over an existing, but I can't have my two roofs in contact with each other. So that fleece tends to give me a barrier between the two systems. All right, this is one thing, and again, when I put these things together, I didn't know that there were 3 types of EPDM on the market. And then there's different grades, I believe, within the different types. So type 1 EPDM is a non-reinforced sheet. So if anybody would say, I need EPDM, and you see on there type 1, and you need reinforced, and that would be type 2. So type 2 designates reinforced sheets internally with scrim. And then type 3 is that EPDM sheet with the fabric backing. So if I have a type 3 EPDM sheet, I have a fleece back. And it says specifier should always specify the thickness. So if you're talking EPDM, it should be say, hey, I want a type 2 45 mil. So now I know as an installer that I'm looking at a reinforced 45 mil sheet. Not the Corona. EPDM membranes are available inside up to 50 feet. I said that. They come folded though, so they're a pain in the butt to work with. Why? Because I can't put a 50-foot roll on a truck. Doesn't fit. Wide rolls eliminate seams, a common point of failure. So with these systems, as I talked about, the seams tend to be the failure points. So not having seams reduces the amount of failure points. Again, anytime you're loading a roof, again, this is handling and storage, always make sure that you know which way the framing goes. These rolls get very heavy, especially when you use a thicker mill. So you always want to make sure you're laying these big rolls out, lay them across the framing. Don't lay them along with the framing direction, because what you're doing is you're overloading an individual member of that building. So you want to spread the load across multiple framing members. So anytime if you're in charge of loading a building, go look inside. If you've got a pallet of goods and it weighs 2,000 pounds and it's 4x5, it's 20 square foot, well, that loads 100 pounds a foot. That's more than the building's designed for overall. Will it take it? Probably. Should you put it over a column? Probably. So again, check the layout of the building before you load it, and try to make sure that you cover your rolls. Look at what your manufacturer says about shipping when you have them. EPDM, my understanding is, guys, that it does absorb some moisture on its own. So you want to keep them covered. You want to always keep all your rolled goods off the roof. You don't want moisture wicking into the rolls, especially if you're adhering them, because the glue and the water don't go together. Anything else on this that you guys can come up with, past experience? Handling, storage?
No, I used the 50-foot wide sheets one time, and I vowed never to use them again.
Once was enough, yeah.
They're too big.
Yeah, no, I've used some pretty wide ones myself, but I've actually found it probably be easier to move them once they were unwound, and then you flutter them and get air on it, and it moves almost like a sheet on your bed.
Yeah, so like flutter it.
You get 3 or 4 guys and you shake it and it pulls air.
Talk to me about one side up versus the other side up. There's an up on these sheets too, right? There's writing on them typically.
Yes, there is writing on them. They're identified, and most of your seams are laid out. I mean, there's lines.
Okay, seam marks on them on the one side.
Yeah, number identifiers and different things to that effect from which plant manufactured them and whatnot. Product identifiers.
All right, we talked already about installing, and again, this is same thing with typically. I mean, I can do a ballasted TPO. So a single ply is typically fairly consistent with installation method, whether it be ballasted, which is loose laying it, basically attachment at the perimeter, and then putting rock on top of it. Again, not a system for South Florida. I'm not even sure that they do it so much in FBC up in the other part of the state. Adherent system means I'm going to glue it. Mechanically attached means I'm screws and fasteners. Now, I can do a hybrid too, depending maybe on my uplift, to where I have to glue and screw some of them to get the uplift that I need. So I might have a hybrid system. Field lap seams in EPDM roofing are typically constructed with an adhesive seam tape or a liquid applied adhesive. Sealant may be manufacturer requirement at field seams or edges. So I may have a seam, it's a seam caulk, right? An EPDM It's not TPO, it's a cut edge sealant.
It's lap sealant.
Lap sealant. So is black comes in a tube typically for black membrane, white, they make, with EPDM, excuse me, if you have white membrane, all the accessories come in white, the caulk comes in white.
Right.
If you have black EPDM, all the accessories come in black. Many of them, at least the ones that are pre-manufactured, just like TPO and PVC, have pressure sensitive tape on the back. So with these seams, you're doing the same basic process. You're gonna make sure your material is clean. You wanna prime it. Different ways to apply the primer a little bit, depending, sometimes you gotta use a scrub pad, and that's if it's new, correct? You want to put it on with a scrub pad. You always want to use, if you're using seam tape, you're gonna use a roller and put it in there and use pressure sensitive, and then you're gonna then make sure that
some of your rolls can come pre-taped, as you know, in order to gain certain parts of warranties, you know, depending on what your warranty requirements are. In order to gain 20 years, they have to be, you know, the tape's factory applied, and it comes out pre-taped on the bottom.
So it would be on the bottom, and then you'd apply the new sheet on top. So then you'd only have to then, James, prime the one you're lapping on top.
Correct.
And some of these, they all come with a release film on them. Some of them, Firestone has like a brown paper on it. Some of them had a clear film. What I understand from some of the installers, that brown paper can be a real pain in the butt to get off. Some of the plastics come off a lot easier.
Absolutely.
Keep rocking and rolling. But again, just like Edgar, did you have a question?
Oh no, it was more where the guys were talking about the 80-foot sheets. I have installed them, and also they come dusted in one side for a reason. Well, they're just literally meant to be ballast, those big rolls. That was it.
So talk to me about the dusting, because I saw that when you, do all factory sheets typically come that way?
No, only, well, I'm sorry. It's just the EPDM sheets. Some of them come dusted. The non-reinforced ones, they come dusted or undusted. And the cleaner is actually black, the ones typically used. I mean, I installed a lot of Carlisle up north because I did a lot of EPDM up there. That's what they use.
You are going to be my assistant in the lab. I got you. Thank you. Thank you for mentioning that.
Hey, Clay, I learned that the dusting was put on there so it helps, so the rubber doesn't stick to itself. It helps to the ease of unrolling it.
But then again, that's something that's got to be blown off before you seam, I take it?
Well, no, it does. It's not that drastic where you have to blow it off. You know, you're going to wipe it off and clean your seams prior to seam taping them. Yeah, that's correct. You're going to clean.
It's kind of like a sand and base sheet that I'm thinking of.
Yeah.
Modified base. Regardless of the installation method, just like any of those other single plies, you got to let the material relax. So you kick it out, you let it sit there and relax, and then you apply it. And half hour typically, maybe it depends on the heat of the day, Frank, as far as the membrane. That sound about right?
Yeah, we just lay them out, 3 sheets. Gives it about a half hour just to relax, just like on TPO or PVC or modified. Just want it to relax.
All right, so as far as installation methods, fasteners and plates are used for mechanically fastened systems. And again, same thing as TPO. They're specified by the length of fastener, to the plate type, number, spacing, typically only at the lap seam. Although what I do see is enhancements, and they use something really like a rust strip. So they put a strip underneath the membrane. It has fasteners. It has the glue strips on it, and then they roll the membrane onto it. Can you guys talk to those?
They lay them out where it's, if you remember when you running your perimeter sheets, you're going to run them the opposite direction of your field sheets. It's the same thing when you use an EPDM and you get to your walls, depending on how many half sheets that you want to run, you're going to pull back your EPDM. You're going to run either a 6 or a 9-inch rust strip, or I'm sorry, it's a 9-inch rust strip. And it's got plates in the middle. The other sides are pressure sensitive tape. you're gonna leave it taped, and then you're gonna measure out on your back side of your EPDM roll, and then you're gonna put a primer. Okay, if you have 3 rolls of half sheets, you're gonna prime your field sheets accordingly, the same measurements that your rust strip is laid out. Then as you roll your primer or your primered sheet, you're gonna peel off that plastic or your brown tape, roll in your EPDM, and then use your hand roller and roll it, and then do the same thing in sequence to your next perimeter sheet. Your next row of rust strip, and the same thing. So then once you get it completed, you'll have a full sheet with picture framed or your perimeter sheets installed from the bottom side. So you just completed all the way to the wall, and then you can even go. In fact, you can do another roll of rust strips to 6-inch at the wall transition, and then glue your wall, and then complete it all the way up and over your parapet. So you have one continuous sheet. You just incorporated your 3 perimeter sheets and your base flashing, or your base tie-in flashing.
Exactly.
Yeah, that's what I was just gonna say, picture framing. So I'm trying to make it so the guys, have the same, because we talked about it when we talked about TPO and PVC. So adhesives, tapes, and primers, conditioners are used in the construction of the seams on the same project. You got to watch which bucket you're using, because you may have more than one adhesive. Maybe a different adhesive installation of the membrane to the substrate. One used to adhere membrane to membrane. So again, different adhesives for different applications. Maybe something different for an edge metal component. May have different primer to work in conjunction with the adhesive also. Now this EPDM comes, I mentioned pre-molded corners, just like everything else, the other things, for ease of installation, for speed, for quality control, so that you're not field fabricating everything all the time. So EPDM sheet flashing typically consists of the same material used for the field. So, but and they do make these, James, out of reinforced material too?
Yes.
Okay. So EPDM sheet manufacturers make available a number of accessory products. Again, pipe boots, and this pipe boot, for instance, here in the bottom right, that'll have pressure sensitive or it'll have a peel and stick application on the bottom. The glue comes on the material, correct?
Correct.
And then it has a plastic strip that you peel off. You roll it in place after you prime it, put some caulk around the edge of it, and then you do your pipe clamp and your caulk around the top, and you've completed the penetration. So I sent these videos out. So I wanted to talk a little bit because, again, so much of setup, installation, I'm gluing the sheet down, I'm mechanically fastening it, here's my pattern, bam, that's all the same. When we get to these seams, this is where the rubber hits the road, no pun intended, because it's rubber root. But this is critical. So it's got to be clean. You'll see the guys typically working together. So I took some stills out of the videos I sent you. So basically they've got this sheet adhered. If I had a mechanically fastened system, I typically have about, correct me if I'm wrong with these measurements, I typically make my seam about 7 inches wide on the coverage, because I leave 3 inches for my fastener, and then I need at least 3 inches for the seam tape outside of the fastener line. Just like we have a weld on TPO outside of the fastener, I gotta put my seam tape outside of the fastener. The system that I'm looking at in these pictures would obviously be adhered, because I've got a 3-inch seam, which I believe, correct me if I'm wrong, I'd set up at a 4-inch, basically, originally, something like that, because I want to always make sure when I do this that my laps, the seam tape, is outside. I got to have about an 1/8 to 1/4 of it exposed outside of that lap when they put together.
But you want no more than that, though. If you do, then you have to use your lap sealant to cover it. So it's really important that when you're marking, because you're going to have your sheets laid out prior to them doing what they're doing, you're going to take a white crayon and you're going to mark it, the outside of your lap, and where that lap is, then you fold your sheet over, then you're going to prime it, and you're going to set the tape it's really vital that you have the same person who's marking it set the tape, because they know where to set the tape. And then once you prime the bottom side of your top sheet, you roll it over, peel the tape off, or the cover strip, then you can roll it, and then you'll have that 1/8 inch exposed. But it's just like when you go back to your coatings, you have to have it no more than a 1/4 inch exposed. This is the same with this. You have to have an 1/8 inch.
So that strip that they're rolling out there and they're putting on, they're taking the top picture in the middle, two guys are doing it, stretching it into place and sealing it. That's real sticky. It's real sticky stuff. And then beneath it, they're rolling it in to make good contact. Well, they want to make sure you roll it. You roll it before you take the paper off, because if you take the paper off, your roller will get stuck. So I don't think this might not have been needed, because you'll figure it out pretty quick on the first time you do it. But again, you just want to make sure that you're putting pressure on the strip on the base, and then in the upper right corner, as they pull, you see him pulling the release paper out, and then he's rolling in the top contact. So he's making contact with the top of the sheet. As James mentioned, these sheets may come with this applied to one point. So again, making sure you've got your sheet in the right place when you lay it out is key. And then I also just looked at a basic repair patch. So what happens is we're doing the same thing. This is on a smaller scale here. James, they must make a pressure sensitive repair material too, or no? I mean,
Yeah, they do.
Yeah, so this is like the hard way maybe, or the field way?
Well, it's yeah, I mean, it's not really the hard way, but you're not always, I mean, that pressure sensitive, essentially the either 9 or 12 inch flashing tape is just more expensive too. So, this is something that, if you have the material and you've got a hole, I mean, you have all of those materials right there when you're doing the project, right? So, that being said, that's really probably the proper way to do it. I would say it's the proper way to do it if you're doing a repair of like a new construction project, something to that effect. Absolutely.
You ever seen a Turnabond used to fix this?
No.
Now, not a joke, everybody, because that's not, unless you just need to come back the next day, a Turnabond's okay. It'll last a couple days, but, and I said that kind of jokingly because we see it all the time on these products, because it does stick. But what happens with a Turnabond, it's got this plastic film on the top, doesn't take long for that plastic film to come off, and then it starts pulling away at the edges. But we see it, and because especially in Florida, there isn't a lot of experienced EPDM mechanics. So you see a bunch of everything in South Florida. You'll see thermoplastics on here. You'll see all kind of coatings, some working, some not. But again, no matter what I do, I always try to go back with a like product. I always try to, what they call when I'm fishing, I match the hatch. Z, you with me out there today? You match a hatch when you're fishing, don't you? First fish you catch, you cut his belly open, you see what he's eating. Then you know what your bait should be, because you want to feed the fish what they're eating.
Yeah.
I want to eat broccoli, I'm not going to eat broccoli. So with the repair, you're putting the primer again, not only on the surface, you put it on your patch wherever your seam tape's going. You're just laying your seam tape in there. And then in the upper right, you're pushing it down. You got to do one side and then the other, because you've got to keep your seam tape, you got to undo one side at a time. And then you're putting the T-joints in, the T-patch covers.
You have to make sure you lap your tape over, and wherever that tape is lapped over, needs to be about minimum 3 inches. But you also got to put, a T-patch, or some manufacturers will allow you to use lap sealant wherever that lap occurs in your seam tape.
So in your bottom left-hand picture, James, is basically what it looks like is if they've almost lapped it 3 inches based on the tab of that paper they've got sticking up there. If you run it all the way out, it's okay too, no?
Yeah. I mean, it's as long as it's a minimum. There's a minimum on it. You can go 6 inches if you want, but you're gonna have to put a larger patch on there. So you also got to understand your materials. And if you're putting on a patch, you don't want your patch on your T patches to be the same size as the patch you're putting on.
No, but look at the picture on the bottom right.
Yeah, I see it.
The T-patches are on those two ends, but where I put the T-patches would have to deal with what I put on top on the bottom left, wouldn't it? Or should I have them on all four sides of that patch?
Mm,
You see what I'm
no.
saying?
Yeah, I mean, no, they would only have to be where the materials. Well, I guess yes. I see what you're saying. Yes, technically,
Yeah.
yeah, there should be one on all fours on four corners.
One's on top, one's on bottom. It's the same.
Correct.
Maybe on the lower one you'd put it, wherever the bottom one crossed. All right, so I'm on an EPDM a few years ago.
If you're doing that, then you should taper that tape or cut it in a way that is angled right there, so you get in the proper lap, but your lap's not extended all the way out to the outer edge. If that.
So you'd almost 45, you dog ear it.
Yeah, kind of dog ear it a little bit right there.
Okay, just like we were doing in the valley. Remember, guys, when you were dog earing those shingles, when you were building that valley on the house? So you cut them back at a 45, like James says, so you don't have the lap in two places.
Or make sure that it stops short of going all the way to the perimeter edge of the other tape.
That'll save you 4 T-patches.
Yeah.
And that wasn't clear in their video, too, so I'll talk to my friend at Firestone. So, again, I walked up on a job not a few years back, and I'm like, what the heck are these? Some EPDM systems have a non-penetrating fastener called a button fastener. I know Carlisle makes one, tends to be round.
ProLink makes one. I think that's a ProLink fastener right there.
Yeah, okay, so I didn't know what, thank you. I didn't know what these rectangular ones were. And you can see in the picture on the right, because of these things go in, they don't go through the membrane. You have something under the membrane, and then you slide this piece, you bend the membrane, and then you slide the top piece of plastic in it. So there is no hole in the membrane at these fasteners. Problem is, over time, they wear out. And I mean, I go up and 50% of these buttons would have patches on them.
Yeah.
And what I did notice, at first I'm like, what the heck are they? I've never seen them before. So then I started to put my roofer hat on, and I'm like, just like Frank talked about earlier, I said, there's more of them at the perimeter, and there's more in the corners yet. It's got something to do with uplift. So again, looking at the conditions that you have and thinking about what all that you've learned may tell you sometimes what you're dealing with. So I just wanted you to know what, if you haven't seen these, Edgard.
Yes.
You do any of these button systems?
Yes, I did a lot of patching on them because they used to split by the button over time and float around.
Yeah, I mean, and again, why? Because you got a stress point there. And not only that, that's holding the membrane down and the membrane's trying to lift up. It's a natural stress point. We are bearing down on it. What's going on around this drain, guys? I just found the picture. I thought it would be a learning point. I mean, age, improper installation.
Pounding water.
Ponding water. That's what, all of the above.
All of the above. Age, improper installation, not enough lap sealing around there. Most of it's probably age, though.
And then if it's you've got a place where the roof has a hole in it, so you might have stresses in that area too, maybe some unusual stresses pulling on it. I saw the importance of sumping these drains in these systems too, and being outside of the sump, maybe with some of your connections, but making sure you got a good slope in the area of the drain. Now, this is something very interesting, and this is a personal story, and I'm running out of time, but I'm going to do my best to get us out of here. It's close to 5. Oh, it's 5 now, sorry. Again, if you want to get off the call, you're more than welcome, but we're 5 minutes from being done, maybe 7. And this is some neat stuff here. I did a job in Miami on the Shriner place, okay, the Shriner building, an old building. They didn't want to spend any money on it, old EPDM roof. They had a roof that was all messed up, 20 by 30 foot section. EPDM. So we went out there, my guys changed the section. It's probably only the biggest EPDM job I ever did, my only one. First time it rained, the guy called me and says, hey, this is leaking worse than it has ever leaked. I'm like, we just put it on 2 weeks ago. So I get in my truck and I ride out there. And the roof was shredded. I couldn't figure it out. I said, somebody's come up here and done some damage to this roof. I didn't leave it like this. I have pictures from 2 weeks ago. About that time, one of those turkey vultures landed on the corner of the roof and started pulling at the roof. Turkey vultures, 2 or 3 different type of birds like EPDM. EPDM has a lot of uses. Not only is it a car tire, it's using the gaskets on your car, the window gaskets. I did a high-rise building in Miami, and the window gaskets were EPDM. I blamed 6 people for tearing up the EPDM with their tie-offs before I figured out it was, somebody called me one day and goes, hey, I found the culprit. When I went up there, it was a turkey vulture pulling at that rubber. So turkey vultures will eat rubber. Be aware if you see birds picking at this stuff, they like it, they'll cause damage, and it'll come back. So maybe reinforced membrane can help, they said. It's not, at least these birds drop clams out of the air and everything else. Any other thing that you've seen with EPDM like that, guys?
I have not.
Yeah.
I have never seen a buzzard.
South Florida phenomenon. Those are dumb chickens down here, we call them. All right, so we've talked a lot about a rust strip. Sometimes they're used for membrane anchorage around perimeters and terminations. For the last, we're done. This is the last couple slides. For the last Uber Eats gift card, what does rust mean? Anybody?
Reinforced universal security.
Hey, not you. Anybody else? Everybody's heard of a rust strip though, right? Did you think Russ was the guy who invented it? Say it again, Frank.
Nope, I'm not saying it again.
Reinforced universal securement strip.
Excellent, Elijah. I'm going to give you the second gift card.
Give it to.
No. It's for your wife. It's for your wife, okay? Because she helps. I know. I appreciate her. So, what else do I got? Nothing. So, does anybody have any questions regarding PDM, regarding liquid applied roofing? I did pretty good. I'm only probably 5:03. So, I put on a 2-hour show, and I did it within 3 minutes. So, I'm proud of myself. I'd like to take a minute and thank Frank and James for their input, because it would have been boring with me, because I would have been basically reading from the book, because like I said, done very little EPDM. Again, it's single ply. It goes down a lot like single ply, but when you start where the rubber hits the road, where you really make the difference is the quality of the details that are involved, and the seaming and the terminations. Is where it really gets critical. And again, Thermoset, something you're going to run into more on the repair side, all you guys in Florida. If you go into other markets, still going down. I think it hasn't, it's after TPO now, right? TPO is the most. You know, James or Frank?
It really depends on the market. Up in Atlanta, we do tons of what they call push and slides, and it's old ballasted EPDM systems, and it's cheaper to just go up there. You don't even have to demo it. Just push this rock over to one side, slice up the membrane, leave it there, and put a new membrane right over top of it, and push the ballast back over.
So you cut the other one, so if you get a leak, you know where it's at.
No, you cut the other one. It release any sort of blistering.
Shrinkage too, right?
Shrinkage, exactly.
Yeah. Any other questions from anybody? Frank, James, any parting comments on EPDM, liquid applied?
No, on the EPDM, you really want to watch your details, just like you're saying. For example, if you got a 20-year warranty, just for example, on your T-patches, there's going to be a certain way to put a T-patch. You got to put a little dab of lap sealant, and you got to put your T-patch, then you got to put a secondary patch on it. Same with your blowout patches on your EPDM. So 10-year, 15, 20-year warranties will determine how you do those blowout patches and your T-patches. But that's just, once again, following your details and knowing what system you're putting down.
So again, what I'm hearing is, you guys that are in production, when you get a job book, read it. When you read, ask questions. That's the best thing to learn. I'm one guy, I'll always tell you, I ask 20 questions. When I'm asking 20 questions, I typically know the answer to 5 of them. because I know that the person I'm talking to knows what the hell they're talking about. Okay, so it's a little game I play.
If you're ever out on the roof and you come across a split, make sure you round the tips of your splits. That will keep it from splitting further in the future. Because what I've seen is guys go out there, they'll patch right over top of the split. And then, you know, the membrane's so tight, it's just going to continue to split and it's going to split out beyond the patch. So if you round round the tips of it, it's going to create that thing where it does not split any further.
I saw that when I was looking at the videos, and I didn't know why they're doing it. So thank you again. Transparency. I haven't done it so much, so I don't know. Have I repaired 30, 40 foot long splits? Because yes, when it splits, sometimes that's when it does split. It splits.
Yeah.
And it keeps splitting, just like you say. So what James is talking about is even a little split. Wrap your scissor in there, cut a circle at the end of the split. What that does is it gives a place for the pressure to release. Like when they're fixing your glass, they'll drill a hole first because it lets that pressure release. So another excellent point. Again, that was worth me tuning in for the whole time. Thank you. If nobody else has anything, like I say, I'm at about 7 minutes over time. So I want to wish everybody a great weekend.